Oh, hey, we're live. Look at that. Super duper cool. Incredible graphic from our design team. Really appreciate their help as well as everyone else's help in putting together our first ever hackathon workshop. Not only that, our first ever live stream from the AO account. It's a pleasure to be here. Thank you so much for tuning in. Hackers, I hope your projects, your agents are going well. Um, I wanted to quickly recap where we are in the hackathon. So as a reminder, the hackathon has commenced. There are 3 weeks to the hackathon. It ends on September 2nd at midnight UTC time. We've got 43,600 US dollar equivalent in prize pool money. Most of that is going to be paid out in our Reef token. But there are bonuses. So not only do we have a 25,000 US equivalent grand prize, 4 different tracks, best documentation, community choice award. We also have 3 bonuses that our 3 sponsors have added as an additional incentive. Once again, Apis has a prize pool for special um, agents that utilize their GPU to compute. We have Astro USD for whoever incorporates the best usage of the brand new USDA stablecoin. And then, of course, Randao. If you are able to incorporate randomness into your agent, there's an additional bonus for that. We will make the winners announcement on September 5th. We've got judges from we're at Community Labs, APIS, Forward Research, 3 technical judges, 2 community judges, all looking closely at your entries. If you haven't been added to the AO Discord, there are special invite-only channels just for the hackers. Give us a ping in the Discord. Say, hey, I don't see what Drew's talking about. No worries there. We'll get you added. Those are just special channels for the hackathon participants to be able to talk with each other, ask our devs questions as you're building out these agents, and just get you all set up here. Now, in the Discord, we've got our a HackMD document that will be circulating. We'll be running through it on this workshop today. I'll also, after I'm done talking, post it as the top comment to this tweet, this live stream. So just running through the workshops we have, because we know AO is new. We know that you're going to need as much help as you can get to build out these agents. We've got 3 workshops just for the hackathon participants and anyone else who wants to build on AO. Today is the first workshop 1. This is sort of like a getting your feet wet, learning the lay of the land from AO. Workshop 2 is next Tuesday. That's going to be a deeper dive into the AI on AO side of things. That's going to be with Apis, Astro, and Randao. And then the 3rd workshop is going to be next Thursday. That's actually going to be in Discord. The first 2 will be live streamed just like this. The 3rd one will be in Discord with our 2 community judges, Jorge and Johnny Ringo. They're going to be vibe coding in the Discord live, answering all your questions and giving you a chance to see how they work. So without further ado, I think we can bring up our 2 guest speakers for the workshop today. That's Nick Juliano and Pete Farmer. Hey, boys, what's taking,
Hey
bacon?
guys, how's it going?
What's up?
You guys are big time now. All right. I love it. Well, guys, I'm super duper appreciative of you 2 taking the time. I know you're super busy working on AO and the background mechanics there. I thought I might just take like a 10, 15-second detour and just kind of ask you. You guys are 2 of the core devs behind AO. Like, what are you doing today? Like, what's going on? I think people would be interested to hear like what's the Forward Research dev team working on right now?
Yeah, for sure. Well, thanks for having us on, Drew. Hey everyone, I'm Nick, developer at Forward Research. Right now, primarily, I'm focusing on actually making the AO Connect SDK backwards compatible with LegacyNet through Hyper-Beam as well. So ideally, over the next few days, we're hoping to release AO Connect in a state where you should be able to just essentially flip a switch, start using Hyper-Beam, and have it be completely backwards compatible with legacy net. Yeah, that's my current focus right now. It's what I'm working on today.
Hey guys, Pete. I'm currently working on kind of CI/CD stuff. So automated deployments to our TE servers and dev environment. Yeah, and doing bug fixes on Hyper-Beam. Yep.
Bugs? What bugs? There are no bugs on Hyper-Beam. Well, gentlemen, I appreciate. I described in broad strokes that we're getting. This is sort of like a little bit of an intro to AO, getting your feet wet. What specifically are can participants expect today? What are they? What do you guys got for them?
Yeah, so our goal for today was to really just kind of give a little introduction to AOS, also talk a little bit about some of the new features inside AOS that come about from Hyper-Beam being deployed, which is actually called Hyper iOS, which is a new, version of AOS supporting all the features of Hyper-Beam. So we'll talk through, some of the new really cool things there. And then we were also going to just walk through building a very simple agent process that, fetches data, price data from an API and goes through a simple trade strategy that basically turns it into an agent process that if anyone feels that they want to move forward with it, they could take it into another workshop or keep working on it outside to really build it out for, a pretty powerful agent process. But we're going to start, pretty basic and just kind of get an introduction to AOS today.
Dude, I love it. I love it. Now, for the audience listening out there, we are taking your questions. You can ask questions. If you have questions, either leave them as a comment under the tweet that you're seeing if you're watching on X, or you can go into the Discord. You can pop it in the general chat. You can pop it in the hackers if you have questions and want to pop it in the hackathon chat. We'll collect those. I'll let Pete and Nick go for a little bit, collect some questions, then I'll come back up for air and I'll read them all. And we'll do that at least one time just to make sure if you're watching this and Peter, Nick say something that you're like, what are they talking about? Don't worry. We're watching all your questions. I'll collect them and read them on air so we can get them answered right here on our inaugural workshop.
Awesome. So hopefully Drew or whoever has shared this HackMD document that Pete and I have been working on to show this agent process. But we were just going to kind of walk through, talk about AOS, take it, one piece at a time, and then kind of have a full agent simulation process that pulls price data and simulates trades, which is a pretty cool first step to having a full running agent process. So just getting started here, first thing we want to do is make sure we have AOS installed. And a prerequisite for that is having Node.js installed. And that link should be in the HackMD document shared as well. But just to walk through it, it's going to enter VS Code here. And paste in the preview AO. Or this could also be found at getao.rweave.net, which has the most recent AOS release. And you can ensure AOS is installed by just going to AOS -- version. And then once you have Node.js installed, preview AO, get AO installed from the npm install command, you should be able to see that you have the most recent AOS client version installed. So what is really cool about this new AOS version is that it's unlocks a lot of the new capabilities that Hyper-Beam comes with, which is really awesome. A couple of them we're going to go through kind of in the workshop, but the first really new cool feature of Hyper AOS that we will go through shortly is called Resolve, which we will look through. But basically, what it allows us to do in processes is actually fetch data from external APIs, get the response of that data, essentially like fetching from an Oracle, and handle it inside, an AOS handler and to be able to set memory and things like that, which is a super cool unlock and feels like a great feature for, an agent specifically for fetching data from, an external price feed, which is super cool. Another cool feature that we felt is worth mentioning that we won't really go through today, but is this new concept of state synchronization in Hyper ALS. I'm not sure if anyone has had a chance to play around with the patch device in Hyperbeam so far, but basically what the new patch device has allowed us to do is expose state um, at the top of a running AO process so that we no longer need to dry run state from that process. But with this state synchronization tool inside Hyper AOS, what we can actually do is just have essentially a global variable like so at the top of an AO process, and then be able to access that memory, that state directly from a Hyperbeam URL just by having this saved in a .lua process, which again, we won't really go through that today, but that just felt like a really cool thing to mention, a really powerful feature of Hyper AOS. But yeah, anyway, so to jump into the process, the first thing I'm going to do, and the next thing we have kind of in this workshop doc is the AOS command to spawn a process. And how we do that is by just saying AOS and then the process name that you want to specify. I'll call our agent process, my agent. You can call that whatever you want. And
Oh,
did you want
also,
to jump in
yeah,
here?
yeah. If you guys want to follow along, the workshop.forward.computer is available for you guys to run through this test as well.
Yes, great point. And shout out Pete, who got this workshop node running today so we could have a working demo, or we hope working demo, but we'll see as we go through it. But anyway, so yeah, like Pete said, this workshop node is here. If you feel like following along, that's awesome. We can everyone can have their own, agent simulation process running by then, which would be super cool. So we have AOS command, process name, and a URL specify, which is the Hyperbeam compute node that will run all of the scheduling and execution of the messages sent to and from this process. So I'm just going to go ahead and spawn this process here. Now with this AOS release, it will ask you to select a version. We'll want to select Hyper AOS, indicating that we want to use this Hyperbeam URL as opposed to legacy net. So I'm going to just select Hyper AOS. And now we have this running process. And just to walk through the code a little bit, we broke it up in this document as kind of three little pieces of first initializing state, and then setting and getting the price data from our external API, and then using a very, very simple trade strategy to simulate trades. So we'll just kind of walk through that one piece at a time. The first block I have here is some just global state that will set inside the process, a prices table to store a global feed of prices that will fetch from a global API. Kind of just this portfolio is really just a mock portfolio to indicate, a starting balance saying, we have this starting balance of USD and some tokens that we want to fetch data and simulate trades on. So first thing I'm going to do is just save this into a .lua file on my drive. And now we have this start of a process here. And what I'm going to do is load this Lua module with the .load command in Hyper AOS. I think that's on us. I don't think we have that in the document. But to load the Lua module into your process, what you can do in AOS is call .load and then specify the file name, which should successfully load it in. We're seeing an error at the moment. We could be running into a little node version issue. Of course, live demos, always something, right?
Were you already using the new agent process name?
Yeah, it could be that I already specified this agent name and that has some problems. So let's go ahead and call this one my agent too. There we go. Thank you, Pete. So now we can see that I loaded this in. We can just view everything that we have in memory directly. And now we're going to add some AOS handler logic to utilize this state that we set here. Now, the next thing I want to do and really emphasize in HyperIOS, which is really cool, is this get prices handler, which is a super new concept in Hyperbeam and one that I think will be a very powerful tool inside AOS, which is this resolve functionality that we kind of brought up at the beginning, which allows us directly from an AOS process to go use the Hyperbeam relay device to actually call an external service, which we have set to this price feed URL, which is, this is nothing more than a mock API that I created yesterday just to dump a JSON list of, some fake price data that we will use for the demo here. But what's really cool is from the Hyperbeam relay device, we can go to this external URL, fetch the data, specify an action for AOS to then listen for, which I'll add the set prices handler for.
Also, one note, you don't need the question mark 2 equals action. We just forgot to modify the doc.
Great point.
Yeah.
Yeah, there's definitely some
I just
confusing syntax in Hyperbeam land but great point, Pete. By specifying this patch device, that allows us to use another action to say that when we get a response from this, we're going to get a message to our own process. But by specifying this action, we can actually handle it inside AOS as well. So we can have another message, get this data that we'll see when we run this in a second, that is going to receive the body of the HTTP response and set the prices data. So now we have direct access to an external Oracle, which definitely feels, again, like a really cool AOS feature. So after I added these handlers, next thing I'm going to do is just load the agent again. These 400 errors are not expected. Next thing I'm going to do is just try another process. Nice. Okay. So now we should have, all our state initialized, our 2 getters and setters for obtaining a price feed. And before moving forward into kind of the basic trading strategy that we have implemented, I'll actually call the get prices handler. So we should be able to see this data come in and set inside the prices table. So we have in here in the document as well, just a way to invoke an AOS message, send an AOS message, which is by utilizing the send command with a target, which is going to indicate where the process will be sent to, and an action, which is going to trigger the handler based on the actions that you have set inside your process. And for anyone who's watching who's very familiar with LegacyNet AOS, there are some definitely key changes in Hyper AOS syntax. One big one being, everything is really to comply with HTTP protocol, more or less lowercase now. So to send a message, you'll use lowercase send, specify a target, lowercase target, so on and so forth, and some other more minor things, but worth noting, like obtaining the ID of a process can now just be accessed through ID as opposed to AO.ID. But really a big one to note is the lowercase syntax now being used inside Hyper AOS. But just to continue on that, I have the get prices action set. I'm going to send it. Now this should be utilizing the Hyperbeam relay device that's going to take a URL that we give it, go out and request that URL. And then we can see that we received the price feed back from the price feed URL that we set. And then the set prices handler was called. And then we can see the updated prices printed out from the Oracle request. So just as I think a super cool feature that we have now in Hyper AOS is going to make it, even more powerful. But yeah, so now we have a mock list of prices set that our agent can actually start trading on. Before we get into the trading strategy itself, we really built out a super simple example for how an agent might behave based on simple trading rules. So we're using a basic mean reversion strategy, which is basically saying for each token, based on the last average price that this token was at, we're going to set some thresholds here that we have marked as band percentage, which basically says if I find the current price of this token and it's above the threshold, that indicates sell position. So I should sell, and vice versa. If it's cheaper than expected or cheaper than the current average, then it indicates that I want to buy that token. So that's basically just the strategy that we're going to implement. Super simple, but a good example of how an agent might behave. Now, before I drop in the actual trade handler, we have some really basic helper functions. I'm not going to write through one line at a time because I already got them typed up here. But just to walk through them real quick, we have SMA prev helper function to basically just grab an average price from the price feed to mark as our last average price. SMA standing for simple moving average. Grab the band values from the band percentage config that we have set at the top here. It basically says when we loop through, look at the current prices, we're going to use this helper to determine buy or sell position and can buy and can sell. Simple validations for the user to determine if they have enough USD, for example, to buy that token. And then we have one final handler to add, which is the trade handler. Again, not going to go through typing out that one at a time, but just to walk through it real quick. When I trigger this trade, basically what it's going to do is find our last simple moving average, loop through each token, find the current price of that token, find the band percentage threshold. If it's above the threshold I have set, we are going to simulate a sell, and vice versa. If it's below, then we're going to simulate a buy. And just before we run this, we kind of know now, though, with this trade mechanism in place, with the price data fetching, we have, a full working agent, which is super cool in a way, for at least, the first workshop of this series to have, trade simulated data being fetched. But a well-rounded working example of what an agent process can look like in AOS. But just to run through it real quick, first I'm going to reload my agent. And then now that I have a prices table fetched, I can send a message to myself and say trade, which is going to go through, the basic strategy that we just talked about before. And we can see output here. It's going to essentially set a cursor to determine the current average price. It's a little bit just a simple way to set the last simple moving average values. But so that all it's saying here is we don't have any prior values to compare on. So you need to run it again. It was probably just set on the first one. So we'll just have the agent process run trade again. And we can see our output portfolio that we have set in state up here. that will update inside the trade handler every time it's triggered. And we can see kind of what happened the next time around. We see the less simple moving average value here, the two bands, kind of the output of what the rules were. And then we can see some trades happened, and we can see our portfolio update indicating we bought some of this token, and we can just run through this, as many times as we want before fetching more price data to kind of have the round trip of, how an agent process can behave. That's really all of the steps that we have, kind of worked out for today. Something we definitely want to get into is running these things, automatically, which we can do with a Hyper-V cron device, which is super cool. And Pete, maybe if you wanted to talk about that a little bit, just to kind of basically what it would be able to do is run all these messages being sent that we kind of just set up automatically on an interval that would kind of unlock, how an agent should behave. But basically, those are all the steps of the process. And yeah, I'll kick it over to Pete to add whatever he thinks.
Yeah, I think people have some questions. Maybe we'll bring Drew back and answer some of those, if that's good with you.
Yeah,
Oh,
sounds great.
whoa. My brain is exploding, gentlemen. I can't take much more of this. I'm loving it right now. We've got like 500 and increasingly growing audience watching. We've got questions in Discord and on X. So people are buying what you're selling. I'm loving it. I just got a couple of questions. So I'll take a little break here. I'll dip back after we're done talking about these questions. So if you have more questions as you're out there, keep on sending them. We're not done taking questions. I just wanted to run through a few right now. We got one from Ankush. Shout out Ankush. Let's see here. Can relay also be used to read state from other processes?
It's a great question. Pete, you want to?
I believe so. Yes, it can. For reading the state, depending on whether it's signed or not. So I think if you're reading state from a process, it needs to be a signed request to get that data. I don't know if that's 100% true, but I think that's the correct answer.
Yeah,
Yeah,
just to add to that real quick. Kind of going back to the state sync that we talked about in Hyper AOS at the beginning, kind of have that exposed state at the essentially tip of your process or most recent message. I don't see any reason why you couldn't use the relay device to then just go call that URL of the exposed state of the other process. So that definitely should work. That's a great point, and Kush, we should try that out for sure.
shout out Ankush. I love it. Another question. What makes message passing in AO different from like calling a function in a traditional smart contract?
So I would probably answer that by saying like the instant finality of sending a message. So I guess there's kind of two ways to answer, but the way I'm thinking about it is like, so on Ethereum or another network, let's say you want to update some state in a process or send a request to another process, you kind of need to enter this pool of contention pool of not having certainty if your transaction will reach the network. You need to like essentially pay gas and compete with other transactions to fit into that block and reach the network. With AO, when a message is sent, it's just sent and scheduled immediately, so there's like no competition with other messages or other processes to have your message sent to somewhere else. So if you want to send a transfer message to someone, you send it, it's scheduled, it's done, which is super cool. As not talking poorly about any other network, but as opposed to another network where you might not know if your transaction would reach the chain, if that makes sense.
Totally. Um, Two more questions, and I'll let you guys get back to your thing here. Like, what is actually happening when we spawn a process on Hyper-Beam? Like, what's under the hood there?
Pete, you want to take that one?
Yeah. So depending on whether you're using Genesis WASM or the Lua device, uh, everything kind of happens on local Hyper-Beam now. The scheduling happens on your local Hyper-Beam unless you have an explicit scheduler set. So yeah, and then or the compute server also runs for legacy processes. So you can spin up, you can call legacy process IDs. It will spin up a local coup on Hyper-Beam, process the local coup, and that information just gets sent back and forth between Hyper-Beam and that local coup. But for Hyper AOS messages, it just all happens on Hyper-Beam and then gets scheduled in our week. Yeah.
All right. And last question, this is probably near and dear to the hackers' hearts. Um, any tips for debugging when things go wrong during development? That's a broad question, but
Yeah, for sure. Tom at Ford has built some awesome testing tools. There's a new library he built called Permaweb Loco that I could find and share as soon as I have a second to dig through and find it. But basically, a local AOS testing environment that allows you to create like a local WASM container and actually load your processes into, which is a super, super helpful testing tool. Um, but also, like at the end of the day, kind of feel like we get into a lot of just old school debugging tricks, like adding print statements into processes and reloading it and seeing the output and things like that. Definitely have to be creative, considering it's definitely a pretty novel programming environment. But yeah, there's definitely some tools that are worth sharing that we'll definitely like find the resource links for.
okay. I'll totally make a note of that. And when Nick and Pete are done, those debugging tools, we'll be sure to circulate those on X and in Discord. Um, we're still collecting questions right now, so you'll probably see me again in a little bit. But I think we're ready to go. If you guys are ready to go, Mr. Producer, feel free to get me out of here.
Pete, I know you had some
Yeah. So
context on more Hyper-V specific things. If you want to jump into that, that'd be great.
So I think we could also show accessing the data through the Hyper-Beam URL instead of using the AOS that link that
Yeah, 100%.
So you have your process ID. We can go to if we know the slot. All right. So we can go to the workshop forward.computer. Wait, can you guys see my screen? Yeah. All right.
Yep, all good.
Process ID, process at 1.0 device. This is I'm explicitly adding this, but you don't have to add it. You can just do the process ID slash. We'll do compute and select a slot. I'm just going to see what's at slot 5 really quick. So you can use the HyperBuddy Explorer here. This will show you the contents of what's the return of compute at slot 5. And if you want to just see this directly, you can also do format HyperBuddy at 1.0. And this will just return that data without having to go to that URL. But here we can see the process state. And for instance, let's see. So this is not the correct slot. Let's try slot 7. So let's go to results/output. Okay, so we can see the prompt here, the data. So here we see the data. So 7 was the correct slot. We can go to data, format HyperBuddy, And let's look at this in JSON. Serialize JSON at 1.0. So here are the results of this is this the current, Nick? Yeah. So this shows all of the current trading values and what is it, SMA?
Simple moving average. Yep.
Yeah. Yeah. What other things you can do? You can do compute at slot. This will tell you what slot the process is currently at. You have now, which will compute up to that slot, which, I mean, it's already computed, so it won't have to do computation. But for instance, if you put in a legacy process ID here and did now, it would start computing up to the maximum amount of slots that that process had. So if you had a process that had 300 slots and you type now, it starts, it spins up the local coup on Hyperbeam and starts processing through those slots. Yeah. Some other cool features, you can use the relay device. And I think it's relay path. Wait, no, it's call. And relay path equals, let's do GPS. For example, let me copy that price feed. So we just sent a relay call to this URL from Hyperbeam, and then Hyperbeam returned the data. And if we look at this through HyperBuddy, we can see that it's a message that it transformed that request into a message. So the message that returned contains the data which has, or the body of that URL. So if we switch this to, you should just see like a error page. But so let's see, the body contains some, let's see what it looks like. Yeah. So forwarded directly to the Google. Yeah.
Yeah, that's awesome. The relay device, like in practice, right in the browser.
Yeah, I'm trying to think of other things to show. We can go over how to install the dependencies that you need for Hyper-Beam on like an Ubuntu 22 server. Yeah, I don't know. What do you think, Nick?
Yeah, I know you had some notes written up on Hyper-Beam installation, and you think it's makes sense to walk through. I think it'd be awesome.
Yeah, Drew, do you want to hop back in and see if is there any more questions?
So let's see here. Is question from the audience. Is this Hyperbeam node for the workshop going to be live for the hackathon's duration? And is this running in a TEE?
This machine is not a T. We spun it up just for the workshop, just so people could use it during the workshop. It probably will not stay live for that much longer, maybe a couple days.
Okay. Gotcha. Sorry, I'm like reading all these because it's a little technical. Can we run? Well, this might be like a hackathon rules question, but let me see. Can we run our own nodes like the workshop.forward.computer address? I'm guessing they mean for like the hackathon rules, right?
Uh,
That's go ahead, Pete.
yeah, you definitely can. You just have to spin up an Ubuntu 22 server on a remote machine. If you're not doing T, at least for T, you need specific hardware to do. But yeah, you just clone the Hyperbeam repo. You do rebar 3 as Genesis WASM release, and you'll have a release directory. You can modify a config JSON or a config.flat, and then that will be used for the initialization of your Hyper-Beam server, I recommend just setting up Nginx and, routing through 8734 to 80. And yeah.
Sure. Two very general questions, just sort of big picture stuff. Like, what would you say is the most important concept for people to grasp before they start building agents on AO?
Nick, do you want to take that?
Yeah. I think one of the biggest for sure is around the whole concept of message passing and like the actor oriented paradigm, which is like definitely a super new, um, I think, concept in the Web3 ecosystem. And the difference that we kind of went into earlier of having this big shared global state that you see in other networks versus AO, where you have this concept of holographic state, where all the state of the processes are made up by the messages that are sent to them and also logged on Arweave. But not having like that big global shared state contention issue where you need to compete for transactions to be stored and have these high gas fees that you send on another network versus AO, where all of the state transitions are done through completely independent message passing. So I guess to elaborate on that a little bit, kind of what we walked through earlier was building an agent process, a process on AO, which you might kind of correlate with a smart contract on another network, can really just be seen as a single, computational unit that has a stream of messages and a, current state that is constructed of just a long chain of messages, and the results of those messages are what make up, um, the state of that process today. It has no like reliance on any other processes running in the network. That's kind of what makes it like, the hyper parallel, horizontally scalable computer. But yeah, I think kind of just thinking about it as like message passing creates state transformations versus like one, giant database or, computer that has like a big shared global state is, I think for, were like my initial thoughts on like, oh, this is super different, super, novel in that way.
And then semi-related question to close us out for this round is like, what are the most common mistakes? What are the things that you like whenever someone says, I got a problem, you go, they did this again. What, like any sort of like beginner tips here that just don't do this?
I would say, at least with setting up Hyper-Beam, using the wrong OS is usually a big thing. Downloading the wrong versions or installing the wrong versions of OTP and Rebar 3. Making sure that you have the correct node and Rust versions. Yeah, mostly the dependencies. After that, Hyper-Beam kind of just works.
I don't know. Okay. Well, John, I gotta be candid with you. I was so busy going back and forth and collecting the audience questions. Is there another part, or were we copacetic? Dude, I love it. I can't thank you enough for taking the time out of your busy schedules to run through this. I can tell by the number of viewers we have and the questions we're getting in Discord. It's immensely helpful. Just recapping once again. The run of show. We have two workshops next week. Next Tuesday, August 26th, if my memory is correct, and then next Thursday, August 28th. The Tuesday workshop on the 26th will be a deeper dive into the the AI on AO components, as well as how to integrate some of our sponsor bonuses. Yes, it's copacetic. That's our producer, like wondering what that word is. That's what it is. That's the word. I'm sticking to it. um, as well as Astro and Randall on that second workshop. And then the third workshop, once again, is in Discord with Johnny and Jorge, who are two community judges. And if you've been in Discord at all, you've seen their names. Speaking of Discord, Discord is your friend. We have live around the clock coverage, direct pipeline to the devs. If you have questions, I mean, we just talked about troubleshooting questions. Pop them in Discord, man. that is your friend for a hackathon or for anything else. And last but not least, a massive shout out to our production team, Peter and Jeff, running the show behind the scenes. Really appreciative of their help in getting us set up. I think I'm good. I think we can close out this Twitter Spaces. Peter and Nick, thanks so much once again. I'm going to do the robot until we're done.
Thanks, Drew.